Hello and welcome to Chapter 5 of BADM323, IT Infrastructure and Emerging Technologies. Implementing new infrastructure requires significant changes in business processes and procedures, training, and education and software integration. This is a task that firms struggle to achieve on their own, which drives the need for these services. The MIS course provides students with an excellent background in a business systems consultant. Most businesses consulting today involves developing of business processes and supporting systems. I would recommend visiting a job or career site to review the kinds of jobs that are available to you with IS or MIS majors. One recent report in 2010 found that MIS majors were the most satisfied group of college graduates because their education led directly to a job. The survey, which was conducted by payscale.com and reported in the Wall Street Journal on October 12, 2010, found that 54% of MIS majors were very satisfied with their majors. Psychology majors were 26%, which were the least. Systems used in many medium and large-sized companies and organizations are so complex that most businesses simply cannot manage all of them on their own. Integration services provided by the likes of IBM and Hewlett-Packard are necessary to simply keep up with the changes. In many ways, it makes more business sense for a company, such as Frito-Lay, to concentrate on its core business of making snack food and let IBM take care of the technology issues. These services become more critical as many companies merge their old legacy systems with newer technologies, such as wireless computing. These legacy systems, some as old as 20 or 30 years, simply cannot be thrown away but must work seamlessly with today's technologies. Companies choose not to totally replace legacy systems because it's too expensive. It involves too much training and carries too much organizational change. It is easier to use middleware and other technologies to merge old and new systems. The bottom line, there are 7 major components of modern IT infrastructure: hardware, platform, operating system platforms, enterprise software applications, data management and storage, networking and telecommunication platforms, internet platforms, and consulting, and system integration services. Melding them into a cohesive system that adequately serves the digital corporation is difficult, but the rewards are many. Business computing is increasingly moving from PCs and desktops to mobile devices, and managers are increasingly using these to coordinate work and communicate with employees. You may think the smartphone that you own is just a phone or music player, but for businesses it is becoming an important management tool. Can you provide examples of how you are using your smartphone in the business or at work? If some of these IT infrastructure components, like storage and telecommunications, have gotten so cheap, why does it seem like companies are spending more and more money on information technology? Because users are demanding better, faster, and easier ways to use computers and more ways to communicate with others. Let's discuss some of the hardware technologies that are helping companies meet the growing technology demand of employees, customers, suppliers, and business partners. If we look at emerging mobile digital platforms, anytime, anywhere, 24/7, 365, that's what computer users now expect. Technology manufacturers are meeting the demand with a host of new communication devices like cell phones and smartphones. The newest gadgets on the market are tablets and e-book readers like the Kindle from Amazon.com or Barnes & Noble's Nook Reader. Smartphones are getting, well, smarter and providing more reasons for users to migrate away from a traditional desktop PC computing. Tablets are miniaturized sub-notebooks that are built specifically for wireless communications and internet access. Even though they may be small in size, they still pack a lot of computing power. In the past, IT departments in large firms dictated to their employees what kinds of devices they could use, both on-site and off-site, while traveling. Increasingly, employees are telling the IT department what tools they want to use and demanding that IT support those tools. In the past, computing devices and software were developed specifically for business applications. Very seldom did the hardware and software spill over into the consumer market. On the flip side, hardware and software created for consumer use saw very little application in the business world. That has changed in the past few years, and as the two have merged and crossed over, now software platforms like Facebook have found a cozy home in the business world. As more and more people purchase smartphones and other technologies for their personal use, they were not content to leave the handy devices at home when they went to work. The consumerization of IT explains the technology along with the BYOD, bring your own device. But, along with bringing their own devices, employees are bringing a new set of problems to the doorstep of the organization's IT department. The most prevalent problem is securing the business's core information system from threats posed by malware and data theft. Access to the corporate network must continue to be protected while giving employees fairly easy access to data, information, and applications. It's a delicate balance for the IT department that must manage and control these consumer technologies while making sure they serve the needs of the business. Looking at grid computing. Both grid computing and virtualization allow organizations to optimize their use of resources in new ways. Grid computing allows corporations to take advantage of spare computing power in the form of networked virtual subcomputers. Virtualization allows companies also to take advantage of spare computing power by allowing a single resource to act as multiple resources. Take a moment to think about how much time you don't use your personal computer. It's actually quite a lot. In fact, most computers are idle more times than not. What if you could combine all the idle time of hundreds or even thousands of computers into a continuous, connected computing capacity to capture, process, manage, store, and retrieve your data? You wouldn't have to purchase mammoth supercomputers to realize this capability and capacity. You just have to turn to grid computing. 3 reasons why grid computing is appealing to companies. They include cost savings, computational speed, and computational agility. When we look at virtualization, server computer hardware prices have fallen over the years to the point where they're relatively cheap. Hence the problem. Rather than increase the efficiency and utilization of existing hardware, many companies just buy more of it and stick it on the shelf. Not much thought is given to the total cost of ownership, also known as TCO, of all the hardware. As it turns out, the TCO is as much or more than the original purchase price, and the hardware utilization rates are extremely low. We'll examine the concept of TCO more at the end of this chapter. For example, let's say you leave your kitchen light burning for 24 hours a day. You only spend about 4 hours a day actually in the kitchen. You end up wasting 20 hours of electricity for those 4 hours of use. Of course, this is a simplified example, but you get the idea of how computer usage is wasted running all of those servers for a fraction of the time they're actually being used. It's not unusual for a company to have one server for this application and another server for that application. The applications are stored on separate servers using different operating systems. It's a very wasteful configuration. Enter virtualization. It's the process of running multiple operating systems and application programs on one machine and increasing the overall utilization rates of the device. Instead of having 10 servers running 10 different applications, virtualization consolidates the programs onto 1 or 2 servers. Here's a list of the benefits that businesses are enjoying from the use of virtualization. There's an increase in equipment utilization rates. They conserve data center space and energy usage. It requires fewer computers and servers. It combines legacy applications with newer applications, and it facilitates the centralization and consolidation of hardware administration. Most companies don't build their own electrical generating plants or their own water treatment facilities. They purchase only the utilities they need, even in peak demand times. Why not do that with computing capacity? If JCPenney.com needs 50% more capacity during a 30-day Christmas buying period, why should it have to purchase that much infrastructure only to have it sit idle the other 11 months of the year? So let's look at cloud computing. It's defined by 5 characteristics. On-demand self-service, which is users can access computing capabilities whenever and wherever they need. Ubiquitous networking access. There's no special device that's necessary for accessing data on this or services. The location is independent of resource pooling. Users do not need to be concerned about where the data is stored. There's rapid elasticity. Computing resources expand and contract as necessary to serve users. And there's this measured service. It's where users pay only for the computing capabilities they actually use. On-demand or utility computing describes a payment structure in which use is dependent upon actual time or power used. Cloud computing refers to a platform, network access to remote services. Cloud computing, they allow organizations to avoid the expense of maintaining their own hardware and software, relying on the cloud instead. Have you used Google Apps or other forms of cloud computing? Are there any other concerns that you might have over transferring computer resources to a shared cloud? Have you read about Amazon Web Services going down and offline for short periods of time? What happens when that occurs? What's the impact to the organization? In cloud computing, the hardware and software capabilities are a pool of virtualized resources provided over network, often the internet. The businesses and employees have access to applications and IT infrastructure anywhere and at any time and on any devices. So within the infrastructure, application and platform services, servers, desktops, tablet computers, smartphones, and laptops can access these services. They don't have to reside on desktop PCs anymore. Data centers will use approximately 2% of all U.S. electrical power. Cutting power consumption in data centers has become both a serious business and environmental challenge. What forms of green computing have you noticed, if any? Some examples may range from more publicized local management of electronic equipment disposable, or recycling to use of solar chargers and so on. Another driver in minimizing the power consumption of computer processors is the proliferation of handheld devices to reduce heat in the devices as well as lengthen time between battery charges. Virtualization that we discussed earlier makes the concept of green computing more of a reality. It allows businesses to reduce their total cost of ownership of hardware through more efficient use of servers, printers, storage devices, and networking equipment. In turn, that reduces the impact on the environment. Power consumption alone raises the TCO of servers to a very high level. Businesses spend as much running a server as they did on purchasing it. Looking at high performance and power saving processors. As businesses require more and more computing capacity, hardware and chip manufacturers are answering the need with multi-core processors rather than a single chip on a single processing core. You purchase a machine with 2 or more processors. It reduces the overall number of servers or processors, thus reducing the total cost of ownership, including electricity costs. The motivation to reduce power consumption is migrating to networks, tablets, smartphones, and mobile computing devices. Automatic computing. As companies rely more and more on IT to meet the user demands, they can't afford to have any system downtime at all. Downtime costs money. Autonomic computing is a step toward creating an IT infrastructure that is able to diagnose and fix problems with very little human intervention. Autonomic computing features systems that can configure themselves, optimize and tune themselves, heal themselves when broken, and protect themselves from intruders and self-destruction. Although this type of computing is still rather new, it promises to relieve the burden many companies experience in trying to maintain massive, complex IT infrastructures. The bottom line: there are many different ways a business can meet its computing demands: mobile, digital platforms, grid computing, cloud computing, autonomic computing, virtualization, and multi-core processing. Although these services may be relatively new, rest assured they will grow in demand as companies require better ways to manage IT infrastructures. Not only is there an environmental concern, but there's also the incentive to reduce costs by developing more efficient and environmentally friendly methods of powering systems. It is within the ability of almost any firm to take measures to go green with their computing. Virtualization is mentioned in the case as an effective way to reduce the total computing resources required to run applications. So what business and social problems does a data center power consumption cause? What solutions are available for these problems? Are they management, organization, or technology? And what are business benefits and costs of these solutions? And should all firms move toward green computing? These are some things to think about as we go through this lecture. What if you bought a beautiful new car with all the fanciest equipment inside, but when you tried to start the engine, nothing happened? How can that be, you ask? The car cost a lot of money and it's brand new. However, as soon as you put some gasoline in the tank, it starts right up and you're moving down the road. You can have all the computer hardware money can buy, but if you don't have the right software, you can't do very much with the hardware that you waste a lot of money on. Let's review some information about software platform trends that help get the most out of your hardware. As we discuss these trends, you'll find a common thread through all of them. They are not restricted to a certain type of hardware or certain brand of software. Security problems in proprietary software are usually discovered by those working inside a particular software manufacturer. The task is often restricted by the number of employees dedicated to the task, resource allocation, and organizational problems that do not confound to open source software movement. Open source software has proven to be more secure than other leading software programs precisely because its code is so readily available, and more people are able to review the code and find out the problems and fix them more quickly. Open source software is not limited to Linux, but includes applications such as Mozilla Firefox, a web browser, and free Office suite, software such as OpenOffice. OpenOffice.org 3 is the result of over 20 years of software engineering. Designed from the start as a single piece of software, it has a consistency other products cannot match. A completely open development process means that anyone can report bugs, request new features, or enhance the software. The result, OpenOffice.org 3 does everything you want your Office software to do, the way you want it. In the early 1990s, a graduate student at the University of Finland wanted to build an operating system that anyone could download from the internet. No one would own, and hundreds or thousands of people would work together on the creation, maintenance, and improvement. He began working on what is now known as Linux, a Unix-like operating system. He posted his program to a web page and allowed anyone to change and improve the code. Its use has expanded rapidly since the small size and low cost make it ideal for information appliances. It's also less crash prone than most other operating systems. That's a feature that makes it very attractive to companies running e-commerce, internet businesses. Linux plays a major role in the administration of local area networks. Around 20% of server operating system market is owned by Linux. Can you give reasons why an open source operating system might be a better choice for network administrators than alternatives that are not open source, such as Microsoft Windows Server? Java is designed to run on any computing device by use of the Java Virtual Machine. This includes mobile devices such as smartphones. HTML is a markup formatting tool that creates web pages that all browsers can interpret and display regardless of the type of manufacturer of the computer being used. Java fulfills the need for interactive programming over the internet. What makes this language so enticing is that it is platform independent. That means you don't need to worry about compatibility between separate operating systems such as Windows, Macintosh, or Unix. Regardless of the hardware or software you use, this language will serve them all. Java creates miniature programs called applets, which perform very small, specialized, one-at-a-time tasks. When a user wants to perform the task, the coding is moved from the server where it's permanently stored and then executed on the client computer. When the task is completed, it's deleted from the client. In a sense, you are an applet once and then literally throw it away. Using applets reduces storage needs on the client computers and PCs. Again, it does not matter whether the client is a PC or a terminal attached to a network. In fact, Java applets are being used on handheld computers and on many other non-computer appliances. Java also reduces the bloatware problem of huge software application programs with more functions than the average person could ever hope to use. You do not need a large application program to do a small task. If you want to calculate the monthly payments for a car loan, you simply use a Java applet instead of a huge spreadsheet program. Looking at HTML and HTML5, it is becoming quite common for the average computer user to create web pages using the hypertext markup language, or otherwise known as HTML. In fact, by using the PC software tools we discussed earlier, such as Word 2010, Lotus 123, PowerPoint, and so on, you can as easily create a web page as you can a letter, chart, or database. Combining HTML language into everyday application is one more step toward integrating the internet into everything we do. The original version of HTML was created when the web was first born. It never took into account that eventually people would want to incorporate audio, video, and pictures within the web. More importantly, the authors of basic HTML language never envisioned that people would want to access the web through a small handheld device, smartphone, tablet, or netbook. As our computing hardware has evolved, so too must the software that provides information to all those devices. The next evolution of HTML is HTML5. The World Wide Web's markup language has always been HTML. HTML was primarily designed as a language for semantically describing scientific documents, although its general design and adaptation over the years have enabled it to be used to describe a number of other types of documents. The main area has not been adequately addressed by HTML is a vague subject referred to as web applications. Firms are collections of thousands of computer programs and systems built over many years. In general, these systems cannot talk with one another, and sharing information among them is very expensive. One way to get to work together is to build software links among them. This is the web services approach. See the next slide on service orientation architecture. Any computer with a browser can access billions of web pages and draw down the information or download PDF files that work on all computers that have a version of Adobe Acrobat installed. In a business firm, you want a similar environment. Any computer program can get data from any other computer program. Web services makes this possible. Web services use internet technology to link application programs together without having to create custom coding. And, as the name suggests, they are web-based, making them more universally accepted within a business or across traditional organizational boundaries, extending to customers, suppliers, and business partners. The distinct advantage of building web services is their reusability. That is, you can build one web service that can be used by many different businesses. This kind of functionality promises a whole slew of new internet-related development companies will spring up in the next few years as this idea takes hold. As we use the web for more applications, computer languages are evolving to keep up with new and innovative uses. HTML has worked well with displaying text and graphics. However, current computing environments demand more. So we look at XML, which is designed to control data on a web page or site and make it more manageable. A white paper written by John Bozak from Sun Microsystems explains XML. He says XML gives us a single human-readable syntax for serializing just about any kind of structured data, including relational data, in a way that lets it be manipulated and displayed using simple, ubiquitous, standardized tools. XML gives us a single, human-readable syntax for serializing just about any kind of structured data, including relational data, in a way that lets it be manipulated and displayed using simple, ubiquitous, standardized tools. The larger implications of a standard, easy-process serial data format are hard to imagine, but they are obviously going to have a large impact on electronic commerce. And it seems clear that electronic commerce is eventually going to become synonymous with commerce in general. XML can do for data what Java has done for programs, which is to make the data both platform independent and vendor independent. This capability is driving a wave of middleware XML applications that will begin to wash over us around the beginning of '99. However, the ability of XML to support data and metadata exchange shouldn't be allowed to distract us from the purpose in which XML was originally designed. The designers of XML had in mind not just a transport layer for data, but a universal media, independent publishing format that would support users at every level of expertise in every language. It's all part of the evolution of the internet. Four software standards and communication protocols provide easy access to data and information via web services. They include XML, which is Extensible Markup Language. It describes data in web pages and databases. There's SOAP, S-O-A-P, which is Simple Object Access Protocol. It allows applications to exchange data and instructions. Look at WSDL, or WSDL, Web Services Description Language. It describes a web service so that other applications can use it. We look at UDDI, Universal Description, Discovery, and Integration. It lists web services in a directory so users can find them. The difference between XML and HTML. In other words, the additional features that XML has compared to HTML is tremendous. These include the classification, presentation, and communicating and storing of data, as opposed to HTML being able to merely present data. These features also allow computers to manipulate documents written in XML automatically. A web service-oriented architecture combines separate applications like a secure, third-party billing transaction with a payment system into one cohesive unit. Service-oriented architecture is a method of developing infrastructure using web services with an eye toward creating applications that draw data from several underlying, usually older legacy programs. All programs are built or redesigned to provide certain information or services to other programs. With service-oriented architecture, developers incorporate each individual service into an application that successfully meets the needs of organizations. The task that Dollar in this example here wants to complete, interacting with other companies' information system, is represented here as a collection of individual services. In keeping with the SOA model, Dollar wants to be able to quickly and easily share data with other companies. The series of services provided above are combined to accomplish this task. So if you look at the web services that Dollar is tying into, it's going to be through Southwest Airlines systems, tour operating systems, travel reservation systems, and wireless website. Dollar Rent-A-Car uses the web service to provide a standard intermediate layer to software to talk to other companies. And it can do this without having to build a separate link in each firm's systems. This slide discusses the trend in software outsourcing and in cloud software services. The internal sources for software refers to developing software fully in-house. Most companies today purchase or lease software or outsource development. So why do you think that software outsourcing is growing quickly in popularity? How about offshore outsourcing? Mostly to India or other English-speaking developing countries. What types of software do you have you used online? Service level agreements are formal contracts between customers and their service providers that define specific responsibilities of the service provider and the service expected by customers. These are important to establish communication between the two firms and to manage the product efficiently. Earlier, we described how businesses are going outside vendors to meet their hardware needs. Organizations are now doing the same for their software needs. Three external sources for software outsourcing are software packages from commercial vendors, cloud-based software services and tools, outsourcing custom application development to an outside software firm, and software packages and enterprise software. Rather than to design, write, test, and maintain legacy systems, many organizations choose to purchase a software package from another company that specializes in certain programs. Let's face it, there isn't much difference in accounting needs and methodologies for a snack food manufacturing than there is for paper manufacturing. So why not purchase a pre-written, fully tested software program regardless of the business you are in? So looking at software outsourcing, companies are discovering that it is cheaper and easier to hire third-party vendors for software-related tasks such as system maintenance, data management, and program development. Much as they have outsourced mundane and repetitive tasks to mainly overseas locations, many companies are outsourcing all kinds of software-related work. The internet has made this option much more viable than it ever was. Looking at cloud-based software services, small and mid-sized companies in need of sophisticated software can rent only what they need and can afford through online software as a service, also known as SaaS providers. For instance, Right Now Technology provides application services via the internet for customer service and marketing programs. Businesses can outsource their accounting needs to a web-based service such as Intuit's online payroll services. Because these services are web-based, data are accessible from virtually any computer connected to the internet. The road warriors love having instant access to documents from wherever they are. Workers can collaborate with others in distant offices through a web-based SaaS. And no one has to worry about their files being compatible with others. They just are. There are some danger to outsourcing your information resources to this kind of service. Remember, all your data are stored on another company's server computers and you have little control of it. What happens if the service provider goes out of business? How secure are data stored on these servers? What kind of scalability and capacity planning has the service completed? These are just some issues that managers must address when they consider using SaaS providers versus in-house technology support. Businesses must exercise caution when using software outsourcing or SaaS providers. We'll call it SaaS providers. If things can go wrong, they likely will. Service level agreements help protect both the customer and the service provider. And here are the main points of service level agreements, also known as SLAs. It defines the responsibilities of the service provider and the level of service expected by the customer, as I previously mentioned. It specifies the nature and level of services provided. There's criteria for performance measurements, support options, provisions of security and disaster recovery, hardware and software ownership and upgrades, customer support, billing, and condition. And customer support, billing, and conditions for termination. With SLAs, corporations have some leverage over their third-party vendors, because if a third-party vendor doesn't meet the service level agreement, a company can enforce contract agreements, such as the third party doesn't get paid until the work is done, or there's a dramatic decrease in compensation to a third party if SLAs aren't met. So this allows companies to really pin the third parties to perform as they promise they'll perform, and doesn't really give them an out or an excuse. Note that the recent jump in SaaS spending within the past several years, and the pronounced rise in the last 2 or 3 years. What are the positives and negatives of acquiring software through the SaaS model? Some of the positives may include it allows companies to focus on business issues rather than on technology. For many companies, SaaS could cut costs. Some of the negatives, SaaS increases the firm's dependency on external suppliers. But what happens if your supplier of SaaS service goes into bankruptcy? What is your backup plan? You may be familiar with mapping services on the web, such as MapQuest.com or Google Maps. These applications provide an easy method to find your way around town. Separately, you may have used a shopping site to locate stores that carry products you're most interested in. What if you can combine these two separate applications into one and make your web browsing easier and faster? Not to mention your offline shopping excursion. That's the idea behind mashups. Mashups combine two online applications, mapping and shopping, into one application. If you'd like to see an example of how convenient mashups are, I encourage you to visit Motomap, that's MOTOMAP.com, and get a consolidated information and maps of motocross and dirt bike trails across the United States. Let's say you're shopping at Macy's and you see a blouse or shirt that you just love. The price seems a little high, but you're not sure that you can get it more cheaply somewhere else. All you have to do is pull out your smartphone, download an app, scan the barcode, and enter a few details about the blouse, and in seconds you'll have information about other places that carry the item, the price, and maybe how many they have in stock. Apps, short for applications, are very small programs that perform a particular task. They can be loaded into your handheld computing device, including smartphones, ebook readers in some cases, or tablet computers like the iPad. Some are free, and others range from about 99 cents to about $4.99. They're generally written by third-party developers following a strict set of guidelines established by the device maker. As the excerpt below shows, third-party companies are now helping small company owners develop their own apps. Tom Johnson is no engineer, but that didn't stop him from creating software that helped him market his wedding video business. Johnson crafted an application, downloadable on the Apple AAPL iPhone, that plays a small video. It connects users to a blog and lets would-be clients call his company. Aligns video products by pushing a single button. Best of all, for a non-engineer like Johnson, he did it in a single day without writing a single line of code. To create the app, Johnson relied on a company called swebapps.com. That's SWEBAPPS.com. One of many new crop of services that help clients order their own smartphone apps, often in less time and for less money than it would be to develop an app from scratch. Like Alliance Video Products, churches, museums, schools, and other small businesses of every stripe can now get into the app-making game, creating downloadable games, travel guides, quizzes, and blog feeds. Thanks to sites like applebeater.com, that's appbreeder.com, appbreeder.com, GameStolid.com, and MyAppBuilder.com. Often all it takes is plugging specs into an online template. Do-it-yourself iPhone apps, Karif, Olga, Businessweek, TechnologyInsider.com, November 1st, 2009. It's worth noting that most apps are developed for a specific device or devices from a specific company. Apps that are written for the Apple company will run on any Apple device. However, apps written for an Apple device will generally not run on any device manufactured or sold by Samsung or a BlackBerry. More and more apps are being created for the business user and lets her access server documents, call up sales data from the corporate database, or schedule meetings with colleagues and customers. So the bottom line, the 5 major themes in contemporary software platform evolution include Linux and open source software, Java, web services, and service-oriented architecture, mashups in apps, and software outsourcing. They are providing companies new options in IT infrastructure technologies. The speed and computing capacity of technology continues to advance at dizzying speeds and in ways we can hardly dream. Star Trek is no longer a vision for the 24th century, but for next week. Keeping up with all those advancements can be a major task by itself. To be sure, it's extremely hard to figure out ahead of time how much computing capacity a company will need. It's like gazing into a crystal ball and trying to discern the future. Managers need to design scalability into their systems so that they don't under or overbuild their systems. The idea is to initially build a system for what the company thinks they need, but to design it in such a way that increasing capacity is a fairly easy thing to do. If the system is more successful than originally thought, or as the number of users increases, capacity can be increased without having to start over from scratch. Now that employees are relying on mobile computing devices to accomplish more tasks, businesses need to develop policies and procedures that are adaptable to the new technology. The issue businesses need to include are inventorying all mobile devices in business use, developing politics and tools for tracking, updating, and securing them, controlling the data and applications that run on them. Firms that use cloud computing and software as a service need to address these issues. Make a new contractual arrangements with remote vendors for IT infrastructure availability. Meet corporate standards for information security. And determine and ensure acceptable levels of computer response time and availability. So how can IT be flexible and still make long-term investments in hardware and software? SaaS may solve some of these problems, but I'm asking you to envision some of the pitfalls of working with an external hardware or software vendor such as Google or Salesforce.com. What are some nightmare scenarios that companies must guard against? For instance, the vendor fails to make critical applications available when needed, poor customer service, and so on. Or the vendor just fails to upgrade equipment in order to save investment money. Technology continues to proliferate in every business, large and small. Users are more familiar and comfortable with technology and usually see it as a helpful addition to the workload. Sometimes, though, that can lead to a disagreement about who will manage the organization's IT infrastructure. Will you have highly centralized control that may stifle the ability of users to get the job done, but provide a cohesive, secure computing environment? Or will you have a decentralized government of information technology that can also create a myriad of problems for the company? Unfortunately, there are no absolute right or wrong answers. These questions must be answered individually for each organization. Electronic business, electronic commerce, and digitization of corporate world continue to grow. The internet is touted as being 24/7, anytime, anywhere. For that model to work, hardware, software, and data must be available 24/7, anytime, anywhere. Companies are rethinking their strategic models for creating, processing, storing, and delivering data to meet the demands of employees, customers, suppliers, and business partners. For a company fails If a company fails to do so, they risk losing business and thousands or millions of dollars. Because of the easy internet access and competition, customers can simply go elsewhere if the company doesn't adjust to the new world. So we look at total cost of ownership, known as TCO, of technology assets. We talked a little bit about TCO earlier. The cost issue is becoming more important to businesses and companies as computer technology and networks grow. Depending on the configuration of the network, a company can save or lose many dollars. What's most important to remember is that the total cost of ownership, or TCO, should extend past the hard dollars spent on hardware and software. The cost should incorporate such items as employee training, their ability to perform necessary functions given the network configuration, and lost productivity when the network is down. The TCO should also include the amount of money spent on communications wiring, such as telephone wires, fiber optic cable, and so on, and security and access issues. So if you look at figure 5.3 in the book, this can help you determine the TCO cost components that you need to consider for your organization. What types of companies should opt to rent as opposed to buying software? Possibly companies with seasonal employees or semi-annual workloads, right? What difference between the two can you point out? TCO is a way of quantifying some of the hidden costs of hardware. Can you make a connection between the TCO of handling software and hardware infrastructure internally as opposed to acquiring it from an outside vendor, if this is an additional incentive to outsource? Does your company spend too little on IT infrastructure, therefore foregoing opportunities for new or improved products and services? Or does your company spend too much on IT infrastructure, thereby wasting precious resource that could be utilized elsewhere? By using a competitive forces model for IT infrastructure investment, your company could align its IT spending with its needs. This includes inventory to market demand for your firm's services, analyze your firm's 5-year business strategy, examine your firm's IT strategy, infrastructure, and cost for the next 5 years. Determine where your firm is on the bell curve between the old technology and the brand new ones, and benchmark your service levels against your competitors. Finally, benchmark your IT expenditures against your competitors. Some of these tasks are very difficult because of how quickly technology improvements come into the marketplace. Even so, it's worth the effort. So our bottom line. So where are we going with all this technology? Computers that are easier to use and incorporated into our everyday lives are in the near future. Improved technologies for business computing are being introduced each day. Faster and smaller information appliances are coming to a store near you. Managers at all levels of an organization will be involved in the process of selecting IT infrastructure components appropriate for the organization's needs, When it comes to the future of computing, our imagination is the only thing holding us back. Can you explain how each item affects a firm's IT services and infrastructure? Do you feel that any one of the 6 is especially important or unimportant? This diagram can also help us diagram a framework for why some firms fail to develop a workable, powerful IT infrastructure.
Now, as you can see, clearly we have a great platform to build games on top of. It's also great for verticals. Salesforce.com is an innovator. They provide software as a service. In fact, are the world leader in on-demand CRM services that are both customizable and extensible. I'd like to bring up Chuck Dietrich to talk you through their experiences with the SDK. Chuck.
Thanks a lot, Scott. Thank you. First, I want to thank Apple for inviting us, and I also want to say how excited we are to take software as a service to the iPhone and bring our over 63,000 platform applications to the iPhone. This SDK is really powerful. The iPhone has a lot of unique capabilities, and our customers are going to love using our applications on the iPhone. To show you this, what we did is we took an SFA application, Salesforce Automation application. Now, many of our million subscribers use this to manage the contacts, accounts, leads, who they're selling and what they're selling. And with the iPhone, you can imagine them in a taxi cab, taking out their device and getting a picture of their business day. They've got their activities for the day. They can swipe into those. They can use the touch screen to navigate the activities, see what are the details. Sales reps would love, in fact, to use the rich graphics to get a graphical view on where they're at against their monthly sales goals. They'd like if we could use the accelerometer to shake them into the green on deals, but we're not going to do that for them. Not going to give them that functionality yet. But what we will give them is with the iPhone SDK, we'll tap into the really rich reporting and analytics platform of our Force.com applications to give them really detailed graphic pictures on where they're at against each of their key business metrics. And you can see we're using the swipe screen to navigate this. And if people know how to use the iPhone, they're going to know how to use our applications on the iPhone. And since the SDK allows us to store the data on the device, connectivity is not an issue. If they're on the plane, no problem. Let's walk you through another example, opportunities. These are the deals that a sales rep is trying to close. Now, you can see it's in the standard table view that iPhone users are used to. They get a high-level overview of each deal. They get a nice graphic view on where each deal's at from a stage perspective. But what's really interesting is the SDK allows us to repurpose the data from Salesforce on the iPhone. So, as an example, maybe this sales rep wants to see what opportunities are most likely to close or of the greatest amount and wants to resort that data on the device so he knows exactly where he should focus his limited days on. With that, there you go. We've got the opportunities sorted by amount on the top, and the rep knows exactly where to focus. Now also, since the SDK can speak to the Force.com API, we can use our advanced workflow triggers or Apex code to actually send more data down to the device when you're in wireless connectivity. In this example, 3 new leads just came in on the corporate website. He can get them on the iPhone. He can open those leads and start responding to them immediately. In this case, Bertha Boxer is a lead. And we can use the SDK to tap into the native functionality of the iPhone, like sending a phone call or an email. Or even more compelling, maybe we want to map where Bertha is relative to where I'm at. Maybe I can stop by and visit her. So we can do this using the mapping functionality. It's very cool stuff. What's really amazing is we only had one developer, Jason over here, up here for less than 2 weeks. And he built all this. Now we have over 70,000 developers developing on our Force.com platform. They are going to love building the next generation of mobile applications on the iPhone. Thank you very much. Thanks.
Well, thank you for joining me on part 2 of Chapter 5. I know this was a lot of technology-driven discussion, but hopefully you got a lot out of it. And of course, as always, if you have any questions, please drop me an email or drop me a note through the instructor's questions in the discussion forum online.